and gentlemen, we're beginning our descent towards Amsterdam Schiphol
You'll have to
Airport.
turn that off, Manessa. Thank you.
Turkish Airlines Flight 1951 is preparing to land in Amsterdam.
Amsterdam, Turkish 1951, descending to 7,000, speed 250.
The crew is flying a state-of-the-art Boeing 737.
Flaps 15.
Localizer alive, localizer capture.
In the final moments of the flight, the landing turns into a catastrophe. The plane falls like a rock. The crash of Turkish Airlines Flight 1951 involves the most popular plane on Earth. With nearly 1.5 million passengers boarding 737s every day, investigators need to figure out if the problem was with the plane or with the pilots flying it. On the morning of February the 25th, 2009, Turkish Airlines Flight 1951 becomes the first plane to crash at Amsterdam's Schiphol Airport in more than 10 years.
It smashed into the ground really hard. It made a tremendous noise.
The plane hits the ground in a muddy field just north of runway 18 right. Since the crash was so close to the airport, rescue workers arrive quickly. Most of the passengers have survived, but many are badly injured. Survivors are taken straight to local hospitals. Images of the Amsterdam accident quickly spread around the world. This is the third crash of a passenger jet in the past 6 weeks. The sudden nature of this accident adds to the mystery. What they know so far is that Flight 1951 had been traveling from Istanbul, Turkey, to Amsterdam. There were 128 passengers on board the early morning flight, including 4 engineers from Boeing.
Ladies and gentlemen, we're beginning our descent towards Amsterdam Schiphol Airport. Please raise your seat backs to the upright position and stow away your tray tables.
There was no mention on board of any kind of trouble in the cockpit. The crash has killed 9 people, including 3 members of the Boeing team and the pilots in the cockpit.
We got a clean recording?
The voice recorder reveals that the 3 crew members began preparations for landing when still above 8,500 feet.
Amsterdam, Turkish 1951, descending to 7,000, speed 250.
But the voice recorder has picked up an unusual sound, a warning that makes no sense at this stage of the flight.
One of the investigators from Boeing was a engineering pilot that came and helped with the CVR. And he's listening to see when, or are there any unusual sounds that can be heard that would not be normal.
Speed okay for ILS 18 right.
Descent 4,000, ILS 18 right.
The alarm keeps sounding. It's the landing gear configuration warning horn. Captain Arasan continually dismisses it.
Turkish 1951, descent 4,000, ILS 18 right. Landing gear.
Is that the landing gear warning? They're at 8,300 feet here.
The warning is a solid clue, but investigators can't yet see how it could possibly have caused a crash. But the flight data recorder does provide some valuable insight into the cause of the landing gear warning. One of the instruments that measures altitude had the plane already on the ground.
When we looked and saw the radio altimeter data, on the recorder it showed about 8,000 feet, and then immediately it went down to about -8. -8 feet is an indication that the aircraft's on the ground, but of course it's still at 2,000 feet.
The Boeing 737 is equipped with 2 separate altimeters. One measures air pressure to determine the plane's height above sea level. That reading is displayed prominently in the cockpit on both pilots' flight display.
10, Set, sir.
The plane is also equipped with a radio altimeter. It's made up of 4 antennas. 2 transmit signals to the ground, and 2 others read the signal that bounces back to determine the plane's height.
It's precise. It's very, very precise. Pressure altimeters can sometimes be not as accurate, and radar altimeters are 100% accurate if they're working properly.
One antenna feeds the reading to the first officer's display. The other feeds the captain's instruments. In the case of Flight 1951, the captain's side was wrong most of the flight. Investigators go back over the CVR and make a puzzling discovery.
Amsterdam, Turkish 1951, descending to 7,000, speed 250.
Standard practice at Schiphol Airport.
I've flown into Schiphol dozens of times, and I expect it.
If the controller's instructions had somehow overtaxed this crew, their conversations would indicate it. They're just 5 kilometers from the runway.
1,000.
Check.
Flaps 40. Speed brake.
Speed brake armed. Green light.
One thing at a time. Landing gear.
Gear down. 3 green.
Flaps.
Flaps 40. Green light.
500.
All lights on.
Please warn the cabin crew.
Cabin crew, take your seats.
Then, real trouble. A stall warning.
Speed, sir.
I have control.
100 knots of speed.
Arisan fought to save his plane, but just 400 feet above the ground and only 1.5 kilometers from the runway, the Boeing 737 suddenly fell straight down. It only took a few seconds for it to hit the ground.
Turkish 1951.
The recording sheds light on the final minutes of the flight. The crew was configuring their plane for landing well after it should have been done.
Flaps.
Flaps 40. Green light.
Most airlines have regulations that call for a flight to be stabilized.
The trouble starts here at 8,300 feet, 13 miles out from the airport, minutes before the crash.
Amsterdam. Turkish 1951, descending 7,000, speed 250.
Turkish 1951, descend to 4,000. Speed okay for ILS 18, right.
Radio altimeter.
Would the crew have known that because of that radio altimeter, they would have gone to a retard flare mode in the throttles? No.
It was a common problem at the airline, but the crew couldn't see the risk it posed this flight.
We have an airplane that was malfunctioning in a very minor way, but in a way that, if not caught, could and did metastasize into something much more virulent.
Turkish 1951, descend to 2,000.
2,000. 1951.
Turkish 1951, left heading 210, cleared approach 18, right.
Left 210, clear ILS, Turkish 1951.
Now left at 210 degrees, maintaining 2,000 feet, brings the flight in right here, 5.5 miles out. They now have to intercept the glide slope from above.
At 2,000 feet, with the glide slope below them, the pilots have to reduce their speed while descending steeply.
Speed 140.
They believe the throttles are moving back for the descent to the glide slope. In fact, the auto throttle is slowing the plane down because it's gone into landing mode. It will continue to slow the plane until it stalls.
What we found is that when the flight crew was doing their before landing checklist, each one of them was doing something while they should have been monitoring their airspeed.
For the next 100 seconds, no one notices what's happening, until it's too late.
Established altitude set.
1,000.
Check.
Flaps 14.
Speed set.
The experienced pilot recognized that the first officer was probably a little bit behind on the approach, so he calls for flaps 40 and moves the lever, informing the first officer that he has done so. He's trying to help the first officer catch up to the position of the aircraft.
Speed brake.
Speed brake armed. Green light.
One thing at a time. Landing gear.
The plane is now 700 feet from the ground.
Gear down. 3 green.
Flaps.
Flaps 40. Green light.
In their haste to complete their checklist, none of the 3 crew members noticed the warnings that their speed is dropping dangerously. First, a red bar appeared on their flight display. Then, when the airspeed continued to drop, a flashing box appeared around their actual airspeed to draw the pilot's attention to it. At this point, no one sees either.
Cabin report confirmed.
The aircraft is now 600 feet from landing.
When things start changing colors, it's a warning to you, it's a caution to you that you're approaching the limits of the aircraft.
Missed approach. Altitude set.
500.
So all of these indications the crew has in front of them saying that the aircraft is slowing down. During that time, they were still completing their checklist.
Of course, the aircraft is getting closer to the ground.
In fact, it's less than 500 feet from touchdown.
And right before the stick shaker started, the captain told the safety pilot,
Please warn the cabin crew.
Cabin crew, take your seats.
Speed sir.
I have control.
Mika Ensley studies the relationship between pilots and technology.
We haven't really designed the automation to take best advantage of what people do well and take away the parts that people don't do well.
In 1996, the crew of an Aero Peru 757 crashed when the pilots couldn't decipher contradictory warnings about their altitude and airspeed. The plane flew into the Pacific Ocean. 61 passengers and 9 crew members were killed. In 1995, the flight management system on a Boeing 757 could and should have steered the plane to a safe landing in Cali, Colombia. But a last-minute change to the flight plan meant the crew had to reprogram their computer. They mistakenly entered a course that took them headlong into a 9,000-foot mountain. 159 people died in the crash.
The cautionary tale here is that we can get this equipment, we can get these silicon-based units, if you will, so sophisticated that we can't talk to them effectively. And when they go berserk, or they have a problem, or we misprogram them, we end up putting ourselves and our passengers in danger while we're trying to figure it out.
NASA is working on something called the Integrated Intelligent Flight Deck. It's a project aimed at helping humans better use the technology that surrounds them in the cockpit.
They're looking at automated flight manual systems, voice recognition systems. They've developed new kinds of microphones that are bone-conducting chips. They're developing new displays for understanding the ground environment, for being able to detect where other aircraft are in the environment.
What some researchers are finding is that the best technology shouldn't replace pilots, but work with them.
Really integrating people with technology more effectively has to do with designing the displays so that you can really understand what it's doing, and you can make it simpler to understand how to make it do what it is you want it to do. You shouldn't have to push 16 buttons through 8 levels of menus to figure out what's going on with the system. It should be integrated and presented effectively. It should be as easy to communicate with as the person next to you.
Boeing and Airbus, the 2 largest manufacturers of passenger planes, take very different approaches to the relationship between humans and technology. Airbus gives the flight computer much of the decision-making power in the cockpit.
In their view, this is a way to prevent a lot of human errors by making sure the airplane doesn't do something that's going to cause a crash, even if the humans wanted to.
But Boeing has a different view. Its philosophy is to provide information to pilots and have them make decisions.
Having more information is better for the pilot, having the pilot in the loop, in the equation, so to speak. I kind of like that.
Airbus will argue vociferously and in continuous fashion that view is archaic and incorrect. I think the jury is still out.
The final report into the Turkish Airlines tragedy blames the crash of Flight 1951 partly on a failure of technology.
The erroneous radio altimeter data caused the autothrottle to go to an improper mode that is, of course, not a good situation.
The cause of the radio altimeter failure was never uncovered. The Dutch investigation asks Boeing to improve the reliability of the system.
We learned a lot about the radio altimeter system and how it affects the autothrottle system. Boeing is currently working on system improvements to prevent this type of autothrottle event from occurring again.
But the report also faults the crew for not noticing that their airspeed was dropping dangerously low, in spite of the fact that there were 3 pilots on board.
Forget that you got an autothrottle. You look at the airspeed, and you look at the altitude. You look out the damn window if you want to, but airspeed is a crucial component of staying alive in an airplane. And you always need to know what your airspeed is.
But to Mika Ensley, the crew's failure to monitor instruments is entirely understandable and may be more the fault of the instruments than the crew.
It's actually very difficult for people to be monitors of automation. One of the things that people don't do a good job of actually is monitoring. We're very good on-the-spot decision makers. We're very good at coming up with creative solutions to problems, but repetitive monitoring is the kind of thing that actually people aren't very good at all. So what we have to do is design automation to work with people in a way that keeps them more actively, cognitively involved and in the loop, and not just monitoring a piece of automation to say, is it doing what it's supposed to be doing?
Who's the ultimate computer? The pilot, the individual who should be able to say, I don't know what this thing is doing to me, but I'm punching it off and flying the airplane. Fly the jet. Probably the smartest thing we ever learned to say in our training in the airlines, fly the jet. Do that first or nothing else counts. That's what they forgot to do.